Okay, so the next problem here, this is example 3, says what if we don't know how many terms there are? So we're just going to find the sum equation for a general series here, a general geometric series there. Okay, so we don't know how many terms there are, so we don't know what our last term is, but you'll see we have this series that goes, S sub n, because we don't know how many terms there are. We have 2 plus 10 plus 50 plus dot, 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 all the way until we get to 2 times 5 to the power of n minus 1. Okay, so that's just our nth term expression there, so we could find any term that we wanted. And let's go ahead and let's follow those 2 steps that we did before, right? The first step there was multiply by r. Second step, subtract the original expression. Okay, so when we do this here, okay, this one might be a little abstract for some of you. And if you don't fully grasp it all the way, that's okay. But hopefully this will help you to see the formula that I'm going to give you here in a couple minutes. So here we go. First thing here, we need to identify what the multiplier is. And I think we know here that r is equal to 5. That one's pretty easy to see. So when we take this here and we're going to multiply both sides times 5, just like we've done in the other one. So we end up here with 5 times the sum of n number of terms. And then as we start to multiply each of these across, we don't know, what terms are all going to be in here. So we'll just do a couple, right? 5 times 2 gives me 10. I have 10 times 5 is 50, right? And then we know the next one would be probably 250 and stuff. I'm not going to write all those in. I'm going to put plus dot, 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 plus. Now, this one would still be, right? This one would be our second to last term. 2 times 5 to the power of n minus 1. And if you think about it, if you multiply that times times 5, if we multiplied this times a 5, right, wouldn't we just add 1 to the exponent, just exponent rules? So our last term here we would get would be 2 times 5 just to the power of n, because negative 1 plus 1 would give us 0. So we have our kind of new series written on there with 5 times it there. Now we're going to subtract the original again. We're going to subtract the entire original series there. So we'll have S sub n equals, we have 2 plus, we have 10 plus, and I'll throw the 50 in there, and then we know that everything's matching up here until we get over here. We've got our 2 times 5 to the power of n minus 1 was our last one there. Okay, this is still just kind of following the pattern that we've been doing with previous 2 problems. Right, you'll see here that the 10s will end up canceling out, the 50s will end up canceling out, the 2 times 5 to the power of n minus 1 will cancel out, and again we would just be left with this and this on the right side. So we'll say 2 times 5 to the power of n minus 2, and that should equal 4 times the sum of the first n number of terms. We divide each side by 4, and we get S sub n is going to equal 2 times 5 to the power of n minus 2 all over 4. All right, so let's kind of look at some of these things here. We already kind of started comparing in that last video. We said here that this value here, right, is like this value here. And we describe that kind of as the next term. Let me get a marker that's thin enough that I can write that. This was like the next term in the series, right? It'd be one that didn't exist up here yet unless we multiplied times our multiplier one more time. We said that over here we had our first term, right? That was our first term of our series. So we're subtracting the first term. And then we didn't really finish talking about down here, this number. Hopefully some of us have picked up on it, we'll see, right? So we're always multiplying s times the multiplier here, and then we're subtracting 1 from it there, right? So this is always going to be 1 less than our multiplier. So, I can abbreviate that probably with like an r minus 1 down here. That's what this is. This is always 1 less than the multiplier, or the geometric ratio, however you want to say it. Okay, so let's write out our actual equation here. So to find the geometric sum, okay, the sum of a geometric series, probably could have typed that out a little bit better. Here's what the actual formula will be. We'll say S sub n for n number of terms. We're going to have our first term times our multiplier, which is r, raised to the power of n. Do you see that? This is the first term. This is my multiplier. And if I multiply it n number of times, it gets me the next term. Okay, so we're going to do first term times the multiplier raised to the power of n. So it's not to the power of n minus 1 here. It's just to the power of n minus our first term, all divided by r minus 1. Okay, if you're looking for like a more like general form or just trying to think of it, right, our sum, right, is going to equal the next term minus our first term, all divided by 1 less than the multiplier. So next term minus first term divided by r minus 1. That is our equations, or our formulas, for finding the sum of a geometric series. So those are important. Hopefully you have those written down here. Do some examples here in the next video.